So in today's session, we are going to discuss about the Python. So here, I mean, in Python, the list, we are going to understand the concept of, we have already seen how the internal structure of the Python list and creation, indexing and slicing operation. And in today's class, we are going to see how the list methods for manipulation and traversal. That means what are the different list methods that are available to work on the list, and some different manipulation techniques that are there. So we are going to see that one. So we already see, so this is the definition of the list. Okay. A list is a sequence of data structures that stores an ordered collection of items, which can be a different data types. That is, list are mutable. You can change their content. List maintain the insertion order. Insertion order means the order in which you are inserted, and list can be heterogeneous. Okay. And here in Python, lists are implemented as dynamic arrays. The dynamic array means the size of the list is keep on changing as we are inserting the elements. So a list stores reference pointers to the actual objects in the memory. So the list items are referred by using a pointer. And when capacities exceed, a large block of memory is allocated and elements are copied. Suppose during the allocation, array is a contiguous allocation. So once it is allocated dynamically, if that allocated memory is not sufficient, it exceeds the capacity, then the content is copied to a new larger block of memory. And the type complexity for order of one for append operation. That means append operation is going to add the element at the end. So that is, it take only one order of n. At the index is also order of one. Why? Because directly we are going. Insertion or deletion in the middle is order of n. N means how many indexes we need to move. So that is the reason it will take order of n. So this is a way how we are going to create a list. So first way is empty list. Second way is using constructor, list constructor. That means we can use this constructor list to create a list. So this is another way of creating a list. And this is list comprehension. List comprehension means we can create a list in a such a way that what are the elements here in the list is x star x, that is square of x for x in range of 5. It starts from 0. So, and it not include 5. So 0, 1, 2, 3, 4. So x star x means square of the number. What is the range? 0 to 4. So that is the reason output is 0, 1, 4, 9, 6, 16. That is 0 square is 0, 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16. So this is also another way of creating a list. This is called as list comprehension. So here, list is a sequence that is supporting indexing, slicing, and iteration. And lists are stored as a contiguous memory block. We already discussed it. It is a dynamic allocation of memory. And lists are mutable. Unlike tuples, when we come to tuples, we are going to see that tuples are unmutable. That means we are not able to change a value or item in a tuple, but whereas in a list we can able to. And Python supports nested list, that is multiple dimensional list, a list inside a list. Uh, this multiple dimensional list inside a list is going to be used for data pre-processing, dynamic programming, and simulations and machine learning also. And in deep learning also, we are going to use nested list and accessing element and slicing. Okay, this is the way how we are going to access the elements in the list. So print data of 0 means first element, and -1 last element, slice from index 1 to 3. Last index is not going to be considered. End is excluded. Okay. And modifying list. So we are creating a list with 2, 4, 6, 8, and we are appending 10. So we are appending 10 after 8, and insert 2 comma 5 means in the index 2 we are going to insert a 5. That means we are updating the value with the 5. Okay. So here we are going to update it. So second element is 6 only. So, or here, sorry, after second element, we are inserting 5. So after 4, we are inserting 5. And remove means we are removing an element 8 from the list. So these are the append, insert, remove, all are methods in list. They are predefined methods in list. Like that, there are so many methods are there in a list. So operations, indexing an operation, append is an operation, insert and delete is another operation, membership test, that is where item is in a list or not, sorting. To sort the elements in the list, just we can use sort. So in the last class, we have discussed that list elements can be change the order. So we can do that order by using sort option. And to traverse an element in the list, we can use in the for loop for n in numbers, colon, print value n. So what it will print? It will print value 10, value 20, value 30. That means it traverse, it will pass all the, it will check all the elements in the number. That means the range, first element it is going to take, and it is going to print n. Okay, n in number. So it is there, whatever the value is there, that is going to be printed. So alternative enumeration means for index comma value in enumerate numbers. So print index comma value. So that means it will print 0, index is 0, value is 1. Like that, it is going to give the enumeration. Okay. So some of the methods that are there in the list are append, extend, insert. These three methods are going to be used for adding elements. Remove, pop, clear can remove elements. Index, count, will search for operation. Sort and reverse, reorder the elements. Copy, shallow copy of the list. Suppose if you want a new copy of the list, we can use the copy method. So these are some of the built-in methods that are available in list. So nested list, 2D list. So a list inside another list. So here, if you observe, in matrix, we are going to represent a two-dimensional array. So that one can be done by using a nested list. So nested lists are going to be used to represent matrices, tabular data, or adjacency list. Like in graph theory, we are going to use to represent the adjacency matrix for a graph representation. There we are going to use the 2D representation of list. List comprehension, that means expression. We are going to create an expression for item in iteratable if condition. So that means, so if you want to create a list, suppose you want to create even numbers in a list in a range. So x, for x in range. So range is from 0 to 10. What are the even numbers? So from 0 to 10, if x modulus of 2 double equal to 0, then it is an even number. So we are going to store that element into the list. Similarly, if condition is optional, okay, if we are not going to give that condition, then other elements, but the 10 value is not going to be considered in that range. It excluded. Okay. So how it is going to store the memory. So it is going to be stored in the heap memory. So lists are going to be stored in the heap memory. Why? The reason is it is a dynamic array. So the dynamic arrays are going to be stored in the heap memory. So here variable mylist stores reference pointer to data. So here it create a reference pointer to the data that is stored in the memory. So the data objects live in the heap while variables names lives in the stack frame. So in the stack variable name, the list name is going to be stored in the stack memory, and the objects of that variable is going to be stored in the heap memory. Copying list duplicate references, not objects. So that is the reason it will duplicate the references. It is not going to create a copying list. Okay, no objects of them. So there are two types of copies are there, shallow copy and decopy. So if you want to perform only copy only references to object, uh, then we are going to use shallow copy, and decopy is going to be used when we want to recurrently copy all the items in the list. Okay. So that is the difference between shallow copy and a decopy. And this is the differences between a comparison between list, tuple, and normal array, numpy array. Okay. So mutable. List is mutable. Tuple is not mutable, whereas the numpy array is mutable. Yes. Data type list mixed. Tuple also mixed. Whereas a numpy array is homogeneous. It will store only whatever the data type of that one, it is going to store that one. Speed, moderate, list are moderate, tuples are fast, whereas numpy arrays are fastest. So if you create an element by using, if you create an list item by using numpy array, then so the accessing is very fast. That is the reason see, NumPy arrays are going to be used for deep learning for the fast computation instead of list. Okay, so use cases are general purpose, and whereas tuples are fixed data, and NumPy arrays are going to be used for numerical operations. So, and real world applications of list are data storage and processing in artificial intelligence and machine learning pipelines. So, in machine learning, we need to store the data, or we need to load the data. The loaded data can be done by using in the form of nested list only. That is only data storage and processing, and also representing matrices, graphs, and data sets. So I already told you now, in machine learning data sets are going to be represented. So it is going to be, and dynamic data management. So here, when we want to implement stacks or queues, we are going to use this list. And text processing and tokenization. So in NLP, natural language processing, their text processing and tokenization can be done by using a list. And extensively used. That means these lists are going to be used in the packages pandas and numpys. So in numpy also, when you are going to create an array, we are going to create the numpy array by using nested list only. So we have done list, different between mutable and immutable data types. Okay. List with Java array list and time complexities, and also how the memory is going to be allocated. So this is the exercise for you. You create this thing. Okay. Write a Python function to flatten a nested list. Flatten means here array list flatten means a column is going to be represented in the form of a row. Single columnar representation is need to be represented in the form of a row. That is the flatten. This one is going to be helpful in deep learning concept. When we are going to complete the convolution neural network, so then see in the CNN, after extracting the feature, we are going to perform the flatten. Okay. And generate the Fibonacci number using list comprehension. So create using the list comprehension, generate the Fibonacci series. Fibonacci series you already know. To generate the Fibonacci series, you need to add the previous two elements and implement matrix addition using 2D list. So this is and count frequency of each element in a list. For example, in a list, we are going to have number one 3 times, two 4 times, five 3, some number of times. We need to find out how many times that particular number is occurred in the given list. These are the exercises you need to do and submit this exercise when you are coming for the uh, offline classes. Okay, this is all about the list. So in the next concept is tuple. So tuple is also similar to list only. Only the difference between tuple and list is tuple is list is mutable, whereas tuple is immutable. So a tuple is in a Python is an ordered in the sense the way how the list elements are going to be stored in an order. In the same way, the tuple elements are going to be stored in an order, and the same way it is going to be printed. That is the ordered. Immutable means once you have insert an element, you are not able to modify the value in the uh, uh, tuple. Okay, and also it is a heterogeneous, not homogeneous. It is an heterogeneous data types. Okay, here there we are going to use square bracket. Here we are going to use rounded brackets to create a tuple. Okay, that is the difference between. See, uh, so list is going to be done by using like this, whereas a tuple is going to represent by using curve brackets. Okay, this is for list. Just remember, list means L now, so it is in the form of a square bracket L, whereas the tuples are in the form of a C. Okay. So coming to the tuples are faster and memory efficient compared to list. So ideal for representing fixed collection of data. So suppose there is no modification in the data, and then we are going to use the tuples to store that such type of data, and used as dictionary keys since they are hashed. So that means in the dictionary, in the next after tuples, we are going to discuss about dictionaries. In the dictionaries, key value pair. So there to represent the keys, we are going to use the tuples. Why? Because the key values are not going to be changed. So preferred for returning multiple values from function. And so suppose function is returning some values. So like in C, we can able to return only one value, whereas in Python, a function can return multiple values. We can see it in the lab part. Okay, during the lab session, we can see how multiple values can be returned by a function. Okay, so we are going to create the how we are going to create a tuple is just to create a variable and assign that variables with the parenthesis with these values. Okay, without parenthesis, we are going to use like this also packing. And if you want to create a single value in the tuple, we required comma after the single element. And also nested tuple. So inside a tuple, we can have another tuple, or it can consist of list also. So four ways we can create. One way is using parentheses without using parentheses. And if you want to create a single value, we are going to create a value and we need to keep a comma. Otherwise, it is not going to be considered as a tuple. Okay. So what are the characteristics of tuple is? Tuple is ordered, maintain the order of insertion. That means the order in which you inserted the values into the tuple. For example, into the tuple, first you have inserted 10. Okay, so it is inserted 10. Next you have inserted 20. So the order in which you are inserted the value, okay, so it is going to be stored in the same order. That is the only order. Maintain the order. Immutable means cannot be modified after creation. Once you have created a value, you are not able to modify the values. Heterogeneous can contain mixed data types. Hashable can be used as a key in data in dictionaries. So it's like accessing the elements in the tuple, the same way how we are accessing the list elements, we are able to accessing the tuple elements by using index value. Okay, so the indexing starts from 0. The similarly -1 will indicate the last element in the tuple, and this one is slicing. So here also it is not going to excluding 4. So first element in the, first index element, so AI, second index element cloud, third index element data, and fourth is not going to be considered. So IoT is not going to be get. Same indexing and slicing syntax as list, and tuple support iteration, but not item assignment. So it will maintain a iteration, but not item assignment. We are not able to assign a value to the item. Okay. So here, if you observe, we are creating a tuple with three variables, three values, John, 28, and engineer. Now, if you observe, we are assigning that values to a variable name. Whatever the value, first index is going to be stored into name. Second index value is that index one value is going to be assigned to A's, and job value, and the third element is going to be index two element is going to be item is going to be stored to job. So this is tuple unpacking. Unpacking means we are unpacking and assign that items to variables. So this is another so A comma star B. See, that means the first element is assigned to A, and remaining all elements is going to be stored assigned to B. Okay, but for B it is going to be stored as a list. The remaining elements are going to be stored as a list. So count of X count returns the number of occurrence of a particular X. So in the previous suppose in a list, suppose in a list you are going to have 10 comma 22 comma 10. If I ask let us say L is equal to, now L dot count of, here instead of X, if I place 10, what happened? So how many times 10 occurred? 2. So it will return, no, it will return 2. Okay. Index X return the index of the first occurrence of X. Suppose I want to know the index of a particular value in the list. So you can use index of that value. But if the value is occur more than once, it will going to show only the first occurrence of the index. See here, t dot count of 10. How many times 10 is occurred? 3 times. So it printed 3. And t dot index of 30 means, what is the index of 30? This is 0, 1, 2. So it print the index of 3. Suppose if I use t dot index of 10, it will print 0. Reason is The first occurrence of 10 is at index 0. So it will give the first occurrence of the index. And if it is not available, it will raise an error. Okay. The difference between a comparison between list and a tuple. Mutability. List is mutable, tuple is immutable. Performance list is slow, tuple is faster. Memory uses list uses high, tuple uses low. Hashable, list not hashable, tuple is hashable. Syntax, we are going to use square bracket, and for tuple, we are going to use rounded brackets. Methods, many, but for tuples, only two methods are there. For tuples, only we have two methods. What are the two methods we are having? Count and index are the two methods. So tuples also store references to immutable objects in heap. Unlike list, the tuples refers array cannot grow or shrink. So the immutability allows tuples to hashable and memory efficient. So as the values are not changeable, we can use to store hashables and memory efficiently. Okay. So remaining we'll discuss in the next class. Okay.